This is a video walkthrough for the Unit 5 review. In 1 through 3, we're asked to find the domain of each rational function. And the domain means the allowable values for x. And the only thing that we have to be concerned about here is division, because division does not yield a result when we divide by 0. So the number that we are dividing by in the formula for f of x is the denominator. So that means that the denominator may not be equal to 0. And so I can solve this by adding 1 and dividing by 3. And that gives us a domain of x may not be equal to 1/3. Basically saying x can be anything except for 1/3. In number 2, if we look at the denominator and we say that denominator may not equal 0, that's just a fact. 3 is not equal to 0. It doesn't matter what x is. So x can be anything. There are no restrictions on x. So that means we can write the symbol, or we can write the words all real numbers. In number 3, the thing that we're dividing by, or the denominator of the fraction, is 2x squared minus x minus 6. So 2x squared minus x minus 6 may not equal 0. And we can solve this inequality by factoring. So 2x minus 3 times x plus 1 is not equal to 0. And so that means that 2x minus 3 may not equal 0. And also x plus 1 may not equal 0, which means that x may not equal -1, nor may it equal 3/2, and that is the domain of this function. So there are just 2 excluded values. In 4 through 7, we're asked to simplify each rational expression, or fraction, completely. To simplify a fraction, factor the numerator and denominator, divide out or cancel common factors, and then write the result. So, in number 4, the numerator, a cubed minus 27, is the difference of cubes, so it factors into a minus 3 times a squared plus 3a plus 9, and the denominator 9 minus a squared is the difference of squares, so it factors into 3 plus a times 3 minus a. The order of the subtraction here is very important. So what we notice is that there are opposite factors, a minus 3 and 3 minus a. When you divide opposite numbers or opposite factors, it leaves you with a result of -1. So the end result is negative a squared plus 3a plus 9, and you can just use those parentheses there. You do not have to distribute, over a plus 3 or 3 plus a. The order doesn't matter here. In number 5, we need to factor the numerator and factor the denominator. The numerator, we can factor out a GCF, or a common factor, of 3. That will leave us with 5 minus y as the second factor. And then 2y squared minus 6y minus 20 does also have a common factor of 2. When we factor 2, we get y squared minus 3y minus 10. We can factor a bit more here. I'm going to leave the numerator because it doesn't factor again, but the denominator has a trinomial that factors into y minus 5 times y plus 2. We'll notice that 5 minus y and y minus 5 are opposite factors. When they divide out, we leave a quotient of -1. So our end result is -3 divided by 2 times the quantity y plus 2. In 6, we'll notice that part of the work has been done for us. The denominator is in factored form. It has three factors. The first factor is m, the second factor is m plus 1, and the third is m minus 1. That being said, the numerator is not in factored form because all of those quantities in the numerator are not all multiplied with each other. So what we need to do is to simplify the numerator by doing the operation. So I'm going to distribute the multiplication of m times the quantity m minus 1, and then add 2m to it. And I'll leave my denominator in factored form. The numerator simplifies further by adding like terms into m squared plus m. And then the numerator can be factored by taking a common factor of m, and that leaves us with another factor of m plus 1. So now we have m times m plus 1 times m minus 1, which means that common factors of m and m plus 1 can divide out, which will leave us with a 1 in the numerator. So the end result here is 1 divided by m minus 1. In 7, we have a similar situation, but in this case, neither numerator nor denominator are factored. That hinges on this plus sign that's sitting here between the 2 times k minus 3 and the 3 times k plus 2. So in order to factor the numerator, we have to multiply it out. So that's 2k minus 6 plus 3k plus 6 in the numerator. And in the denominator, we can factor a GCF, or a common factor, of k squared, leaving us with another factor of k minus 3. In the numerator, when we add together the like terms, we have 5 times k, and in the denominator we have k squared, but remember that k squared means k times k, so I'll rewrite it like that, and then we can cancel those common factors of k, or divide them out to give a quotient of 1, and the end result is 5 divided by k times k minus 3. In 8 through 15, we're asked to perform indicated operations and simplify completely. So in 8, we have two fractions that are multiplied together. When we multiply fractions, we can divide out or cancel common factors before doing the multiplication. So I'm going to factor the numerator of the first fraction, a minus 3 times a plus 2, and factor the denominator, a plus 2 times a minus 2, and then factor the numerator of the second fraction, a minus 2 times a plus 1, and then factor the denominator of the second fraction, 3 plus a times 3 minus a. Pay careful attention to the order here. Since the 9 comes first in the expression we just factored, then the factors have 3 as the first term. We can cancel some common factors, a plus 2 and a plus 2, a minus 2 and a minus 2. 3 minus a and a minus 3 are opposite factors, so that will leave us with a negative 1 when we divide those factors out. Now, collecting all of the factors that remain, we have negative quantity a plus 1 divided by a plus 3, or 3 minus a. In 9, we have division of fractions. In division of fractions, we're going to change this to multiplication, and we're going to invert the second fraction. So, m cubed plus 8 factors, that's the sum of two cubes, so it factors into m plus 2 times m squared minus 2m plus 4, and then m squared plus m in the denominator factors into m times m plus 1. We're changing that division to multiplication and inverting the second fraction, so the m is going to go on top, and m squared minus 2m plus 4 goes on the bottom. Don't worry about factoring that, because you'll notice that now we have a common factor that's identical to that can cancel or divide out. So we're going to now cancel common factors, the m squared minus 2m plus 4 factors, and then the factors of m, and that leaves us with a final result of m plus 2 divided by m plus 1.
Apologies for